Good evening, everyone. Today we'll start Unit 2 of AS Chemistry. The first topic in this unit, intermolecular forces. You will find this topic of intermolecular forces in Unit 1 as well, but not in detail. In Unit 2, it's in detail. Basically, intermolecular forces refers to force between the molecule. And in this topic, you will learn what kind of intermolecular forces exist between the covalent substances or covalent compounds. First, just a quick revision of the structure or the shapes of the molecule. This we already discussed in Unit 1. It depends on the number of the bond pair and the lone pair, the structure or the shape of the molecule. So example, we have a molecule which is having 2 electron pair and both of them are bond pairs and there is no lone pair. So what will be the structure? The structure will be linear with a bond angle of 180 degrees. An example of such molecule like carbon dioxide, carbon disulfide, hydrogen cyanide and beryllium fluoride. If double bond or triple bond is there, we'll consider when we are predicting the geometry or the shape of the molecule, we are considering them as one. Reason for that, because they're directional, means they're in the same direction. So the geometry of the molecule is not affected by double, triple, or a single bond. It depends on how many bond pairs in different directions. So example, first beryllium chloride, 2 bond pairs, there is no lone pair on the central atom. We always check because chlorine belongs to group 7. As chlorine belongs to group 7, 1 is a bond pair for chlorine and 3 are the lone pairs. But we are not predicting the geometry according to the chlorine, we are predicting according to the central atom, which is beryllium here. So if we have like carbon dioxide and we are predicting the geometry for carbon dioxide, what will be the structure geometry? Carbon share maximum 4 electrons and each oxygen share 2 electrons. So on oxygen there are 2 lone pairs and bond pair, one of them is involved in the bonding. When we represent, so there's a double bond between carbon and oxygen. So when we are predicting a geometry, this double bond, because it's in one direction, so we'll consider that as 1, and this is also a double bond, consider as 1. So for predicting a geometry, it will be linear with a bond angle of, because it makes 2 bond pair and the bond angle will be 180. So when bond angle is 180, it will be linear. Same thing, hydrogen cyanide, the central atom is a carbon. Carbon share 4 electron, 3 with nitrogen and 1 with hydrogen. So this triple bond for predicting a geometry we'll consider as 1, and hydrogen and carbon we also consider as 1. So the bond angle will be 180 degrees. So it will have a linear structure. If 3 bond pairs are there and there is no lone pair, then it will be trigonal planar. So trigonal planar, like if you want to draw the structure of nitrate or the carbonate or sulfur trioxide, basically nitrogen belongs to group 5. So it is having 5 electron in the outermost shell. So if it is having 5 electron in the outermost shell, it can share only 3. So this oxygen, each oxygen can share two. So this oxygen share, example, two electron with this nitrogen. So one is left, that will share with other one. So remaining, because nitrogen belongs to group 5, 3 it shares, so remaining are 2. So the 2 are there. Now what happened for oxygen to be stable, but from where this electron is present for oxygen, this oxygen will have a negative, because oxygen belongs to group 6, so 6 electrons are there, 1 2 3 4 5 6. So from where this extra electron is there with oxygen, so this oxygen took that extra electron from another atom. That's why there's a charge negative, but because it's a part of the molecule, the whole molecule will get a negative or -1 charge. And this oxygen having a 6 electrons in the outermost shell, but it need 2 more to be stable. So there is no, well, the lone pair on the nitrogen is available, so it will try to form a bond with this lone pair. So that will be the structure of nitrate ion, in which one is a dative bond and then a double bond with oxygen and a single bond with oxygen, and the whole molecule is getting a negative charge due to one of the oxygen which is having extra electron. Now, when we are predicting a geometry, a dative bond, a double bond, triple, they are all considered as one. So this is one bond, this is a second and third. So when three bond pairs are there and there is no lone pair, the bond angle, the angle between the bonds will be 120 degree with a trigonal planar geometry. Is it clear? The geometry of this molecule? Any doubt in this part? Trigonal planar means the central atom should have three bond pairs and there should be no lone pair on the central atom. So when you draw the structure, according to the structure, you will predict the geometry. Like example, if I want to draw the structure of carbonate, or I want to draw the structure of nitrate. So first I will draw a structure in which all the atoms are stable. So nitrogen belongs to group 5. So as it belongs to group 5, nitrogen can share 3 electrons. And each oxygen belongs to group 6. So each oxygen can share 2 electrons. So what happened in nitrate ion? One of the oxygen form a double bond with nitrogen. So this oxygen is stable. Then another oxygen which is having 7 electrons. So how oxygen can have 7 electron? Means it took one of the electron from another atom. So that's why it is -1. It will share 1 electron with nitrogen. So 8 electron, this oxygen is also stable now. But what about nitrogen? If it shared 3, there is one lone pair is there, but that lone pair is also occupied. How it is occupied? Because one of the oxygen which is having 6 electron, it form a dative bond. Means what is the meaning of a dative bond? When both electrons are shared from one atom, we call that as dative bond. So nitrogen, oxygen, oxygen and oxygen, and the charge on this molecule is -1. So when you check the central atom, when you check this central atom, nitrogen, this is because double bond or triple bond, when we are predicting a geometry, they're considered as one. So this is a one bond pair. This is a second bond pair, and this one is a third bond pair. So three bond pairs, and there is no lone pair. Whenever a molecule is having a three bond pair and there is no lone pair, then what will be the structure? It will be trigonal planar with a bond angle of 120 degrees. Is it clear now? So basically, you have to draw the structure and then predict the geometry. Without drawing a correct structure, you cannot predict the geometry of the molecule. And this is the geometry of the covalent molecule or dative molecule which are having a dative bond. Same thing, a tetrahedral geometry. Tetrahedral means that four bond pairs and there is no lone pair. We call that as a tetrahedral. So example, if I have silicon tetrachloride. So when I have silicon tetrachloride, silicon belongs to group 4. So silicon will share 4 electron and unshared will be 0 on silicon. And chlorine share 1. So each side chlorine shared 1. Now if you want to predict the geometry of this molecule, so the central atom is a silicon, central atom 1 bond pair, 2, 3 and 4. There are 4 bond pair. Whenever there are 4 bond pair and there is no lone pair, then it will be a tetrahedral structure. And when you represent a tetrahedral structure, what is the meaning? Like if silicon is there, 2 chlorine are in the same plane, one of them will be in and one is out, like a 3D structure, and the bond angle will be 109.5. So these molecules, silicon tetrachloride, sulfate, chlorate, ammonium, they all have a tetrahedral structure. Why ammonium is having a tetrahedral structure? Because when you draw the structure of ammonium ion, so ammonium is NH4. But how it is formed? Nitrogen belongs to group 5. So it will share 3 electron with hydrogen. So that's ammonia. All are stable and there's a lone pair. But this lone pair, if there's a proton or nearby hydrogen ion is there, that is attracted towards the nitrogen lone pair. So it, because both of the electrons are shared by one of the atom, that's why we call this as a dative bond or coordinate covalent bond. But when we are predicting a geometry, we'll consider that as a simple covalent when we're predicting. So 1, 2, 3 and 4 bond pair and there is no lone pair, then what will be the structure? The structure will be tetrahedral with a bond angle of 109.5. So you have to memorize these bond angles as well according to the geometry. Is it clear, the structure of ammonium ion? Any doubt in this part? Then if we have 3 bond pair and 1 lone pair, then it will be trigonal pyramidal. Means the central atom. So first thing, when you are predicting a geometry, you should draw the structure to identify that which class of the molecule it belongs to, like how many lone pairs are there and how many bond pairs. So if there are 3 bond pair and 1 lone pair, then it will be trigonal pyramidal. How to draw a trigonal pyramidal? Like example, we have say phosphorus trifluoride. Phosphorus belongs to group 5. It share 1 with fluorine. Fluorine belongs to group 7, so it will share 1 only. Another fluorine also shared 1. So each phosphorus, the central phosphorus atom having 1, 2, and 3 bond pair. So there are 3 bond pair and 1 lone pair, and lone pair is repulsion is more. So what will be the structure or the geometry? So it will be trigonal pyramidal. And how to draw a trigonal pyramidal? The lone pairs are there. One of them is out of the plane, one is into the plane, and one is in the same plane. In, out, and in the same plane. This is how we draw, and the bond angle will be 107. It's easy to remember the bond angle because every lone pair decrease the bond angle by 2.5. That's why if 4 bond pairs were there, then bond angle was 109. But if 3 bond pairs are there and 1 lone pair is there, so each lone pair decrease the angle by 2.5. So 109 minus 2.5, 109.5 minus 2.5, that's equal to 107. Same thing if 2 bond pairs are there and 2 lone pair, then further the angle will decrease 107 minus 2.5, so that is equals to 104.5. If we have 2 bond pair and 2 lone pair, then it will be a trigonal then it will be a bent or a V shape. The best example is water, H2O, because the central oxygen atom, so if we draw the simple structure to identify what will be the geometry, like in case of water, water is H2O. So oxygen belongs to group 6, so it will share 2 electron. It share 1 and the second one with hydrogen as well. So when you check the central atom is having 2 bond pairs. So there are 2 bond pairs and there are 2 lone pairs. So what happened, because the lone pair repulsion is more, it caused the geometry, the angle between, decrease the angle between the two atoms, the bond angle, and this bond angle will be 104.5 degree. So you just have to draw the structure and identify according to the question that what, according to the central atom, how many bond pairs are there and how many lone pair, and according to that you will predict the geometry. Then if 5 bond pairs are there and there is no lone pair, then it is known as trigonal bipyramidal with a bond angle of 120 and 90 degree. So you can see this bond angle, this bond angle is 120 and the other angle is 90. And the example is PCl5, phosphorus pentachloride. So the phosphorus pentachloride, basically phosphorus belongs to group 5, as it belongs to group 5. Phosphorus, when we write the electronic configuration, look, phosphorus is 15 and 31. So it will be 1s2, 2s2, 2p6, 3s2, because we have to arrange 15 electron, 3p till here 10, and 3p3. Still 3d is there, but that is not occupied. The shells are there, but that is not occupied. So what will happen, because still empty d orbital or 3d orbital is there in phosphorus, because there is 3s, there is 3p, and there is 3d. So phosphorus can arrange or adjust more than 8 electron in the outermost shell. For the other element, like there are other elements as well with this case, that because of incomplete orbitals, they can adjust more than 8 electrons. So not only 8, they can adjust more than 8. So what happened in case of phosphorus? It can adjust more than 8. So phosphorus belongs to group 5. So as it belongs to group 5, it should share 3 electron. But because there is an empty d orbital, in case of phosphorus, so it can adjust more than 8 electron in the outermost shell. So as it can adjust more than 8 electron in the outermost shell, the number of the bond pair present on the phosphorus will increase. Now it will become 5 bond pair and there is no lone pair. So if 5 bond pair and no lone pair, then it will be trigonal bipyramidal. Fluorine is there. One is out of the plane, represented by dash. One is into the plane. This is a 3D drawing represented by these symbols. One fluorine up, one fluorine down. The bond angles are 120 and 90 degrees. So PCl5, PF5. PF5 is actually, because it depends on the existence of a compound, depend on how what are the reactant for. There are many reasons, like some compounds exist, some does not. There's a term you will study in A2, which is known as entropy. So using entropy, you can predict whether a reaction is possible or no. If 6 bond pairs are there and there's no lone pair, then it will be octahedral with a bond angle of 90 degrees, in which 2 of them are out of the plane and 2 of them are into the plane and 2 of them are in the same plane. Is it clear? This is the same thing we already discussed in unit 1, the shapes of the molecules. So in exam, you will find a question, a dot and cross diagram, like they asked, draw a dot and cross diagram and predict the shape of the molecule or predict the bond angle. Any doubt in this part? Now what happened? What happened in, like, if we have a double bond or we have a triple bond? Basically, we are discussing about the covalent bonds, covalent structures. Example, if this is a carbon nucleus, the carbon nucleus contains 6 protons and it contains 6 neutrons. First shell, it will have 2 electrons. Second shell, it will have 4 electron as it belongs to group 4. This is one carbon. Then this carbon form a bond with another carbon. Like example, if I'm drawing a structure of ethane, eth means 2 carbon and ane means they have a single bond. So in case of ethane, in which we have C2NH6, so the 2 carbon atoms are forming a bond, a covalent bond is there. So this is a nucleus of the second carbon, in which 6 protons and 6 neutrons are there. Then the first shell and the second shell. Second shell, reason why I overlap the second shell, because it's a sharing of electron between them. And then for hydrogen, 1 proton and 1 electron. This is in terms of nucleus and shells. 1 proton in the nucleus for hydrogen and 1 electron is being shared. the one proton, the central, and the second first shell, it will have one electron that is being shared, one proton in the center and the shell, and there is a sharing. So this is a structure of a covalent structure of ethane. Now what happened, what is a covalent bond? Basically this shared pair is attracted towards the nucleus, and this shared pair is also attracted towards the nucleus, which is keeping them, which is keeping, electron is not stationary, electrons are moving, but that is responsible for the bond, the force of attraction between the electron, shared electron, and the nuclear charge or charge in the nucleus. But if the bond become, like this is a single bond, but if there is a double bond like ethene is there, so in case of ethene we don't have these. So what happened, the two electrons which are here are also involved in the bonding. So now four electrons are there and attracted towards the nucleus. So as four electrons are there, multiple bonds are there, the attraction will be stronger because there is a greater charge. This is a negative charge, nucleus is a positive. Negative charge, nucleus. So there's an attraction between positive and negative or unlike charges. So what happened? Due to this attraction, the strength of the bond will increase. So double bonds are stronger than single bond. And it reduces the bond length. Bond length means the half of the intermolecular distance between the two nuclei. This half of this distance is called a bond length. Because the attraction is stronger, so what happened? The size reduce. As the size reduce, the bond length will decrease. So if we have carbon carbon single bond and carbon carbon double bond, which will be shorter? Which bond will be shorter, single or double, in terms of length? So the double bond will be shorter, and which will be stronger? So the double bond will be stronger, or double bond require greater amount of energy to break as compared to a single bond. Now electronegativity and intermediate bonding. So basically what is electronegativity? Electronegativity is a tendency of an atom to attract the shared pair of electron. That tendency is known as electronegativity. And as we go down the group, electronegativity decreases. Why down the group electronegativity decrease? Because more shells, as we are going down the group, the number of shells are increasing, number of electron in the last shell remains same, more shell, so the distance between the nucleus and valence shell electron or the shared electron the force between the nucleus and electron decrease. That's why as we go down the group, the electronegativity decreases. But as we move across the period, what we observe when we are moving across the period, we observe the electronegativity increases. What is the reason? Moving across the period, electronegativity increase because same number of shells but greater nuclear charge, because as we move across the period, the nuclear charge or the number of the proton increases. So greater attraction between electron and nucleus. So as we know, if I draw the first period, what we have first period, we have hydrogen and helium. These are the two elements in the first period. But for helium electronegativity, we cannot, because the definition of electronegativity is a tendency of an atom to attract the shared pair of electron. But in case of helium, helium is not sharing any electron, so its electronegativity is not there. But when we check the second period, we have lithium, beryllium, boron, 3, 4, 5 carbon, atomic number 6, then nitrogen, atomic number 7, oxygen, atomic number 8, fluorine is there, atomic number 9, and neon is there. But for group 8, we don't consider because they're not forming a bond. So which one in this lithium, beryllium, boron, carbon, nitrogen, and fluorine you think will have the highest electronegativity? Which element across the period 2 will have the highest? So fluorine will have the highest because moving across, the charge is increasing, the number of shell remains same. So fluorine, so the most electronegative element is fluorine. And how we measure this electronegativity? We measured this electronegativity in a Pauli scale. Basically, the Pauli scale is ranges from 0 to 4. The maximum, the highest value is 4, and the minimum value is 0. So most electronegative elements, we have fluorine, oxygen, and nitrogen. Now, what is the effect? This, because this electronegativity is having an effect on the intermolecular force or the force between the molecules. This part already I discussed how electronegativity is affected by size and the charge of the nucleus. Now, due to the electronegativity, what happened? We can identify or we can predict the type of the bonding between the two atoms. Look, this is statement. If a compound containing element of different electronegativity, hence a very large electronegativity difference which is greater than 1.7, then compound will be ionic. Means when we calculate a difference between the electronegativity of the two elements, and if this difference is more than 1.7, then this compound will be ionic. But if it is less than or equal to 1.7, then it will be covalent. Is it clear? The idea, like example, you want to identify, say, lithium chloride, sodium chloride, and the electronegativity difference is 1.9. What kind of molecule, what kind of bonding it will have? Ionic or covalent? So greater difference is there, electron actually being transferred. If electronegativity is more than 1.7, then it will be ionic. But say methane, in which carbon forming a bond with hydrogen. So what kind of bonding it will have? When you Pauli scale, you don't have to learn or memorize this scale. If a question is there, like predicting the type of the bonding, that scale will be given to you, so you don't have to memorize any values for this. Example, you calculate a difference and you're finding 0.3 is a difference, electronegativity difference. So what you can predict, you can say that this will be a covalent bond. Then when a molecule is having a covalent bond, then there are two possibilities. It can be polar covalent bond, it can be a non-polar covalent bond. So for covalent molecules, if the bond is formed and the bond is covalent, then there are two possibilities. It can be a polar covalent bond. It can be a non-polar covalent bond. Example of polar covalent bond, a bond will be covalent, but what is the meaning of polar covalent? Because what happened when the bond is formed between the two elements, atoms which are having a difference in the electronegativity, even though the difference is less than or equal to 1.7, but still there is a difference. So what happened, like example, a bond is formed between hydrogen and chlorine. Chlorine is more electronegative, having a greater difference. So what chlorine tend to do, it attract the bond pair more than hydrogen because it has greater tendency or high electronegativity. So what it cause, it cause a shifting of the electron pair, the bond pair, towards unequal distribution or shifting of the bond pair towards one of the atom. So when bond pair is actually shifted towards one of the atom, still the bond is there between the two atoms. So we write a partial negative on the atom which is more electronegative and partial positive on the atom which is less electronegative. So we call this kind of covalent bond as polar covalent bond. But if there is no difference in the electronegativity, like example, a chlorine is forming a bond with another chlorine. I'm representing dot and cross and using a different symbol to represent the electrons of two chlorine atoms. So here both chlorine have the same tendency to pull this electron pair. So both cancel out the effect of each other and this will be uniformly distributed. This bond pair is uniformly distributed between the two chlorine atoms. So if the bond pair is uniformly distributed between the two chlorine atom, this type of bond, a covalent bond is there, but that's a uniform distribution. So we call that as a non-polar covalent bond. So if the atoms have the similar electronegativity, it is not necessary that always identical atoms, their bonds are non-polar. So they may have like two different atoms, but if they have the similar or same electronegativity, then the bond will be a non-polar covalent. Is it clear? The difference between a covalent, polar covalent bond and non-polar covalent bond? Any doubt in this part? A covalent bond is formed by sharing of electron. Any doubt in this? A polar bond, when two different atoms are there, one atom attract more the pair bond pair more than the other. So there will be a partial negative on one and partial positive on the other one. So this type of a covalent bond is known as a polar covalent bond. But if there is equal attraction, then we call